In Module 3, Section 1, we're going to be introducing polynomials. In this module, we're going to talk a lot about polynomials and different operations with polynomials. So we just want a good grasp in Section 1 of what that means. And we'll start with just the definition of a polynomial. I'm going to type this out. So a polynomial is an expression with one or more terms containing a combination of constants and variables raised to positive powers. So an expression with one or more terms containing a combination of constants and variables raised to positive powers. Well, we're going to be seeing a lot of examples, but maybe if I just give you one quick one here. One example could be just a very basic one. X squared plus 2x minus 1. It has multiple terms, has 3 terms. One of the terms is a constant, just -1. 2 of the terms have variables raised to positive powers. So that would be an example of a polynomial. Now the degree of a polynomial, the degree is just the highest power of a term in the polynomial. The highest power of the term in the polynomial. So if I look at the previous example, if I use that example, I don't want to use that, I'll use a pen. If I use that example from before of x squared plus 2x minus 1. Well, this term has a power of 2. This term has a power of 1. This term has a power of 0. So the highest power, or the degree, comes from this guy. The degree is 2. Okay, let's look at some more examples. First part just says determine if the expression is a polynomial, and if not, explain why. So looking at the first one, remember we need multiple terms with either a constant or variables raised to powers. This one definitely has that. That's x to the third, that's -3x, and that's 12. So yes, that is a polynomial. If I look to the one off to the right, I see 3 terms that would qualify as a polynomial, but this is our issue. A polynomial we can't divide by a variable. So this is going to be not a polynomial. And I'm going to say because we can't divide by x. The next one, I have the square root of x minus 1. Again, not allowed to have radicals in our polynomial. So I'm going to say no square roots can be a polynomial. The square root means it's not a polynomial. And then our last one, we haven't seen an example quite like this. We have multiple variables in each term, all raised to positive powers. That's completely okay. So this is yes. That is a polynomial of 2 variables. Okay, if we look at the next part, it says just find the degree of the polynomial. And if we remember, the degree is the highest power of a term. So if we look at the first example, I see the highest power is going to be 3. So that means I have a degree of 3. Again, I knew that because this term has a power of 3. This term just has a power of 1. It's x to the first. This term has a power of 0. If you just see a constant, that's always a power of 0. So the degree here is the degree 3 polynomial. If I look to the right, I have, again, 3 terms. And what we need to do with these is we need to make sure we account for all the powers. Now, we had talked about before, if I just have x, we can say that's x to the first power. Well, a first power and a second power combined would give me a third power. So I'm going to say that term has a degree of 3. If I look at this next term, again, we can say that's y to the first. So a fourth power and a first power give me a power of 5 for that term. The third term, again, we can assume that's a power of 1. So this combined for the third term is the power of 1, or 1 degree. What's the highest degree of those? Obviously, the 5 is. So this is a 5th degree polynomial. Continuing with this strategy, if I look at the next polynomial, 4 terms, I have to analyze what's my highest power. Well, it looks like from this first term, I'm going to get a degree of 6. And that's definitely going to be my highest power. So this is a 6th degree polynomial. The last one, we don't have a variable. And we had talked about, I'll highlight it right here, that 12 had a power of 0, or a degree of 0. So I can say if I just have a constant 12, negative 12 there, that's going to give me a degree 0. Lastly, we're just going to talk about writing polynomials in either descending or ascending order. Most commonly, you're going to see polynomials written in the future in descending order, but it is also possible to write them in ascending order. One of those two, just some type of order, is always nice when you talk about polynomials. So what we want to know with descending order is that our polynomial is going to go from the term with the highest power to the lowest power. So highest power all the way down to the lowest power. Ascending order, just the opposite. Ascending order, we're going to start with the terms with the lowest power all the way up to the terms with the highest power. So if you're confused on what that means, let's just take a look at the 2 examples that we have here, or several examples, excuse me. Move this down a little bit. The first 2 says, write the polynomial in descending order. So that means highest power to lowest power. So I'm going to look, I have 4 terms here. I have 4 different terms. And if we start with the highest power, because that's what descending order means, that means x to the 7th, or a degree of 7, comes first. So that term is first. Next would be, we'll call that 1 actually. Let me erase this and put a little 1 right there. Next would be x to the 3rd, for the 3rd degree. So I'm going to say minus 12x cubed. I'm going to stick that minus with it because it's still a negative 12. Third would be just the x term, so positive x or plus x. Fourth would be the constant, plus 2. So we're just rearranging things from highest to lowest. If I look at the next example, 3 terms. This first term has a degree of 3 because x to the first and x and y squared gives me a degree of 3. The next one has a degree of 5 because 4 and 1 gives me 5. The next one has a degree of 1. So that means this is my highest term. So I'm going to put that power in term first. There's my next, plus xy squared, excuse me. And then this is my last one, minus y. So again, descending the largest power to the smallest power. Ascending, just the opposite. So now I'm going to number from these 4 terms in order from smallest degree to largest. So 1 would be the smallest, so I'm going to call that number 1, 1. Negative y would be next, so minus y. That third power would be after that. And finally, here's our fourth, minus 12y. It's supposed to be a minus sign. Minus 12 y, or minus y to the 12th power, excuse me, minus y to the 12th power. Last example, again, we have 4 terms. We should think about, okay, our smallest one is definitely that negative 75, so that goes first. Next, well, this has a degree of 1, this 4y, so that comes up next. So I'm going to put that. This xy, remember, has a degree of 2, so that's my third highest. And then x cubed y to the 6 has a degree of 9. So that'll be the last term I put on here. And that's labeling polynomials or writing them in ascending order. So with all this information, use these notes to work on section 3.1. And that's it.